Hi, I am CVR. Now we'll discuss freely falling body and vertical projected body. What is the freely falling body? If the initial velocity of the body is zero, then that is called freely falling body. Suppose from this point to the ground is at a height capital H. How here? How the our kinematic four equations are changes in this freely falling body. What is the first equation of motion? The first equation of motion is V is equal to U plus AT. So here, what is the V? Velocity after some time t. So initial velocity of the body is zero. Now what is the velocity of the body after some time t? That is U is zero and here A value is minus G. A value is minus G. So here V is equal to minus GT. This is the velocity of the body after some time t. So here the minus sign indicates that the velocity of the body after some time t is in the downward direction. So that is V is equal to minus GT. Next, what is our second equation of motion? S is equal to ut plus half at square. S is equal to ut plus half at square. So here u is 0, initial velocity 0 into t plus half A value is minus G, that is acceleration of the body is acceleration due to gravity. So minus G into t square. So here minus half gt square. So here the minus sign indicates that the displacement of the body after some time t is in the below the reference point. Here displacement of the body after some time t is the below the reference point. What is our reference point? From where we have to project the body, that is the reference point. Here S is equal to minus half gt square, where this minus sign indicates that the displacement of the body after some time t is below the reference point. Suppose if body is on the ground, if a body is on the ground, then the body reaches to the ground, then the displacement of the body is replaced by minus h. Because why here we took minus h? S is replaced by minus h. Because the body is the after some time t, the body is the below the reference point. So that's why you took minus h. So minus h is equal to minus half gt square. So from this t is equal to under root 2h by g. T is equal to under root 2h by g. This is the time taken by the body to reach the ground. If your body is dropped from the top of a tower of height h, then the time taken by the body to reach the ground t is equal to root of 2h by g. Next, what is our third equation of motion? What is our third equation of motion? V square minus u square is equal to 2as. So here initial velocity of the body is 0. So V square minus 0 square is equal to 2 into A value is acceleration due to gravity, that is minus G. And here S is replaced by minus H. Suppose if the body reaches to the ground only, then S is replaced by minus H. So here minus H. Now in this case body is on the ground. So here V square is equal to 2gh and V is equal to root of 2gh. This is the velocity of the body after here. This is the velocity of the body to reach the bottom of the surface. So here initial velocity of the body is 0. Here as time passes, the velocity of the body increases continuously. That is reaches to the ground. That body have a maximum velocity. What is the maximum velocity? V is equal to root 2gh. That is our third equation of motion. Then what is the fourth equation of motion? Fourth equation of motion is Sn is equal to u plus a into n minus half. Where here initial velocity of the body is 0, a is minus g into n minus half. That is Sn is equal to minus g into, this can also be written like this. So 2n minus 1 by 2, Sn is equal to minus g by 2 into 2n minus 1. This is the displacement of the body in the nth second. This is the displacement. Where here this minus sign also, the body is below the reference point. This is about the freely falling body. In case of freely falling body, the initial velocity of the body is 0 and the acceleration of the body a is replaced by minus g. In case of freely falling body, the acceleration is replaced by a is equal to minus g. So after some time t, what is the velocity of the body? V is equal to u plus at, u 0, a value minus g, v is equal to minus gt, and s is equal to u2 plus half at square, u 0, so s is equal to minus half gt square. If finally body is on the ground, then only s is replaced by minus h. Suppose the body is somewhere here after some time t. Now this displacement is not minus h. Now here body reaches to the ground, then s is replaced by minus h, minus cancel, h is equal to half gt square. Here this t is equal to root of 2h by g. What is the t? T is the time taken by the body to reach the ground. T is equal to root of 2h by g. Next, what is the v square minus u square is equal to s? U is initial velocity of the body is 0. So v square minus u square is equal to 2 into a is minus g into s is minus h. So v is equal to 2gh. This is the velocity of the body just to reach the bottom of the suppose if you consider this as a tower, then this v is root 2gh. So here what is this formula? When you will apply this formula? If your body is dropped from the top of a tower, suppose you consider this is as a tower. This tower has height h. Then the final velocity of the body to reach the ground, v is equal to root of 2gh. Next, what is the displacement of the body in the nth second? Sn is equal to u plus a into n minus half. So here a is replaced by minus g by 2 into 2n minus 1. Now this is about the freely falling body. Now we will discuss vertical projected body. Vertical projected body. So here this body is dropped from the ground. So here we given some velocity of the body. Initial velocity. Then the body reaches to the somewhere here. Now this is the initial velocity of the body, vertical projected body. So in this vertical projected body, how our kinematic four equations will change. What is the first equation? V is equal to u plus at. So here u is the initial velocity. Initially the body having some velocity, that is u. So here u is replaced by u. Positive u or negative u means here velocity is upward direction. So here u, a is replaced by minus g into t. So this is the velocity of the body after some time t. So here v is equal to u minus gt. This velocity v is continuously decreases because the velocity of the body is upward direction and acceleration due to gravity acting downward direction. So that's why the velocity of the body continuously decreases, and after some time t, the velocity of the body is 0. This is the velocity after some time t. The body reaches to the highest point. At highest point, v is equal to 0. The body reaches to the highest point. So here, this point v is equal to 0. So here 0 is equal to u minus gt. So gt is equal to u, t is equal to u by g. This is the time taken by the body to reach the maximum height. That is called time of ascent of the body. What is time of ascent of the body? Time of ascent of the body is u by g. If a body is projected with a velocity is u, then the time of ascent of the body is u by g. And here this is the highest point. At highest point, what is the velocity of the body? Velocity of the body is 0. The time taken by the body to reach the highest point A, that is called time of ascent. Then what is our second equation? In case of vertical projected body, what is the second equation? S is equal to ut plus half at square. S is equal to ut plus half at square. Here u is u only, positive u into t plus half into a value is always minus g. A value is always minus g, that is minus g into t square. This is the displacement of the body after some time t. S is equal to ut minus half gt square. This is the displacement of the body after some time t. Then what is our third equation? Third equation is v square minus u square is equal to 2as. V square minus u square is equal to 2as. So here v is the final velocity and u is the initial velocity. So here v square minus u square is equal to 2 into a value is minus g. A is always minus g. Minus g into, this is the displacement s. This is the relation between the initial velocity, final velocity and displacement. V square minus u square is equal to minus 2gs. Suppose at highest point, suppose if the body reaches to the highest point, if the body reaches to the highest point, the velocity of the body is 0. If body reaches to the highest point, velocity of the body is 0. Now how this equation changes? 0 square minus u square is equal to 2 into a is minus g, and s is, if the body reaches to the highest point, this s is, this is the maximum height. That is, s value is h. S value is h. So here s is replaced by h. So here minus u is equal to minus 2gh, minus cancel. From this we have two formulas. From this here we will get two formulas. One is u is equal to under root 2gh and another one h is equal to u square by 2g. H is equal to u square by 2g. So here how much velocity is given to the body? How much velocity is given to the body? How much velocity is given to the body? The body reaches to the height h. That velocity v is equal to, u is equal to, that velocity u is equal to root of 2gh. Next, similarly, here what is the maximum height reached by the body? So here this velocity u is given, that body reaches to the height, maximum height. That maximum height formula, what is the maximum height? This is what we call as maximum height. This formula is called maximum height. What is the maximum height reached by the body? H max is equal to u square by 2g. This is about the third equation of motion. Next, what is our fourth equation of motion? Fourth equation of motion is Sn is equal to u plus a by 2 into 2n minus 1. Sn is equal to u plus a by 2 into 2n minus 1. Where here u is u only minus g by 2 into 2n minus 1. So this is the displacement of the body at the end of nth second. This is the displacement of the body at the end of nth second. Sn is equal to u minus g by 2 into 2n minus 1. Next, once again summary, freely falling body and vertical projected body. In case of a freely falling body, in case of a freely falling body, in case of a freely falling body, initial velocity of the body 0 and a is equal to minus g. Then here we have a two formulas in case of freely falling body. Suppose if we consider this is a tower, then the time taken by the body to reach the ground is t is equal to root of 2h by g. Then what is the final velocity of the body to reach the ground? V is equal to root 2gh. Next, main formulas. In case of vertical projected body, the time of ascent of the body is time of ascent is u by g, and next here the maximum reached by the body h max is equal to u square by d, and this velocity u is equal to root of 2gh. That velocity v is u is equal to root of 2gh. Next, what is the time of flight? What is the time of flight? Time of flight. Time of flight means the time of ascent plus the time of descent. The time of ascent plus the time of descent. What is the time of ascent of the body? U by g. What is the time of descent? The time of descent is root of 2h by g. The time of descent is root of 2h by g. So here u by g plus root of 2 by g. So here this h is maximum height, that is replaced by u square by 2g. So here 2 cancel. That is this is root of u square by g square. This is the time of flight. So time of flight is equal to u by g plus u by g. This is u by g and this is u by g. So total time of flight is equal to 2u by g. This is the time spent by the body in air. So time of ascent is what? U by g. But the time of descent, that is also u by g. So here time of ascent and time of descent both are same. The time of ascent plus time of descent is called time of flight. That time of flight t is equal to 2u by g. Next, one more case. So here this is the third case. In this third case, this body not freely falling body. Third case, this body is not freely falling body. So here initially some velocity is given to the body. Here suppose this is the tower of height h. Now this body is at a height h. Now initially the velocity of the body not zero. So here velocity of the body having u. Initially then the body is thrown in the downward direction. So initially the body having some velocity. Now this is not freely falling body. Now in this case, how our equations are changes? What is the first equation? V is equal to u plus at. What is the first equation? V is equal to u plus at. So here in this case, u is not 0. So here u is not u. U is because here velocity is a vector quantity. So velocity is in the downward direction. So we consider upward velocity as positive and downward velocity as negative. So here in this case u is minus u. This is minus u and a is minus g. So here this is about v is equal to minus of u plus gd. Now here this minus sign indicates that after some time the body is somewhere here. The velocity of the body is in a downward direction. Next, our second equation, s is equal to ut plus half at square. S is equal to ut plus half at square. Now in this case, what is the initial velocity of the body? Now also that is minus u. Minus ut minus of dt square. This is our second equation. Next, what is our third equation? What is our third equation? So here also, in this case also, if the body reaches to the ground, then if the body reaches to the ground, S is replaced by minus H. So S is replaced by minus H. Minus H is equal to minus ut minus of dt square. Now H is equal to ut plus of dt square. H is equal to ut plus of dt square. Next, what is our third equation? How the third equation will change? Third equation. What is the third equation? V square minus u square is equal to 2as. This equation is given in so many times in the entrance exam. Based on this equation, they given a problem. So here v is v only. U is again, that is minus u whole square is equal to 2 into a is minus g into and s. This s is what? Suppose body reaches to the ground. If the body reaches to the ground only, s is replaced by minus h. Then, so here that is minus h. Here s is replaced by minus h. So v square minus u square is equal to 2gh. This is our third equation of motion. Then what is our fourth equation of motion? Sn is equal to u plus a by 2 into 2n minus 1. Sn is equal to u plus a by 2 into 2n minus 1. So in this case also, u is equal to 0 minus g by 2 into 2n minus 1. This is the displacement of the body at the second. Okay. Now this case is body is thrown in the vertically downward direction with some velocity. What is our first case? First case is freely falling body. Second case is vertical projected body from the ground. And third case, vertical position in the downward direction. Next, fourth case, vertical position from the top of a tower. Fourth case, this is our fourth case. So our fourth case, what is our fourth case? Vertical position from the top of a tower. Vertical position from the top of a tower. Suppose this is a tower height h. Here this has a tower height h. This is a tower height h. Then the velocity of the body is given like this. This is what? Vertical position from the top of a tower. This is a tower of height h. Then this vertical velocity is given at the top of a tower. Now the path of the body is like this. This is the path of the body. Now this is the path of the body. Now in this case also apply our four equations. In this case also apply our four equations. What is the first equation? V is equal to u plus at. V is equal to u plus at. The velocity of the body after some time t. So here u is initial velocity. Initial velocity is in upward direction. So upward direction velocity is positive. Upward direction velocity is positive. A is always minus g whether the body is going vertically projected or whether the body is going in downward direction. If body is in air, then simply A is replaced by minus g. V is equal to u minus gt. V is equal to u minus gt. So here consider this as a point A. This is as a point. This is as a point A. and this is as a point B, and this is as a point C, and this is as a point D. Suppose here, if V value is positive, if V is positive, it indicates that the body is in between A and B. If V is positive means it indicates that the body is in between A and B, because upward direction velocity positive from A to B, that is upward direction. If V is positive means it indicates that is in between A and B. That is in between A and B. If V is 0, if you got V is 0, then that is at highest point. Then that is at highest point. Then that is at highest point. So that is at highest point. V is 0. Now if V is negative, if V is negative, then that is in between B and D, because that is in the downward motion. So A to B is in the upward direction and B to D is the downward direction. So here if V is negative means that is in between B and D. Okay, this is about our first equation of motion. At C, what is the velocity of the body? At C, the velocity of the body is 0 because there is no displacement. So here at the same points in the vertical position, in this case in the upward motion and in the downward motion, at this point the velocities magnitudes are same. So here at point A, that is upward direction, and at point C, that is in downward direction. Next, second equation of motion. What is our second equation of motion? Second equation of motion is S is equal to ut plus half at square. S is equal to ut plus half at square. Okay, this is our second equation. This is about our second equation. So here u is what? Initial velocity, that is positive value, because upward velocity, initial velocity is upward direction, so that value is positive. So u into t plus half into a value is minus g into t square. So S is equal to ut minus half gt square. This is the displacement of the body. This is the displacement of the body after some time t. This is the displacement of the body. This is the displacement of the body after some time t. Now in this case also, if the body is in between A, B and C, S value is positive because the body is above the reference point. If you got S value is negative, then that body is below the point A. If the body is below the point A. Now, if finally body reaches on the ground, if finally the body reaches to the ground, then this S converts. What is S? S is replaced by how much? S is replaced by minus H. Why you put minus? Because that is the below the reference point. So here at the initially, this is initial position, finally body is here. So at the time of our observation, so here body is below this reference point. Body is below this reference point. If the body is below the reference point, you consider that displacement is negative, and if the body is above the reference point, that displacement you consider as a positive value. So here S is replaced by minus h, u only ut minus half dt square. Minus h is equal to ut minus half dt square. This is very important in the examination point of view. So many times based on this, that is given in JEE mains and NEET also, right? This is about the S is equal to ut plus half at square. Next, what is our fourth equation? What is our fourth equation? Not fourth. So this third equation. Then what is our fourth equation? Third equation. Third equation S is equal, not S. V square minus U square is equal to 2AS. V square minus U square is equal to 2AS is our third equation of motion. V square minus U square is the 2AS is the third equation of motion. So here also V square minus U square is equal to 2 into A value is minus G and S value is minus H. When the body reaches to the ground, only S is replaced by minus H. When the body reaches to the ground, when the body reaches to the ground, when the body reaches to the ground, then only S value is replaced by minus H. So here V square minus U square is equal to 2GH. From this we can write V square is equal to U square plus 2GH. This is about our third equation of motion. Then what is our fourth equation of motion? Fourth equation of motion for this case, Sn is equal to U plus A by 2 into 2n minus 1. So here U is U only, minus G by 2 into 2n minus 1. This is the displacement of the body at the end of nth second. This is the displacement of the body at the end of nth second. So here till now we discussed 4 parts. What is our first part? First part, freely falling body. This is the first part, freely falling body. Next, what is the second one? We discussed till now. What is our second part? That is from the vertical projected body. That is from the vertical projected body. So here initial velocity is given. So here at this point the body reaches to the height, velocity 0. This is the freely falling body and this is the vertical projected body. And next, third one, discuss what we discussed in the third one. Third one is, what is the third one? Freely falling, vertical. Next, third one, vertical position from the top of a tower. Third one is, this is a tower. We consider this as a tower. Vertical position, vertically downward position from this top of a tower. Okay. Next, fourth one, vertical position from the top of a tower. So here vertically downward projection from the top of a tower. This is, and fourth one, vertically upward projection from the top of a tower. What is the fourth one? Vertically upward projection from the top of a tower. This is vertically upward projection. Vertically upward projection from the top of a tower. This is the vertically upward projection. This is the vertically upward projection. So here initial velocity is given. Okay. This is the freely falling body and this is the vertical projected body and this is the vertical projection in the downward direction, that is vertical projection in the upward direction. So in this case of freely falling body, the side is H, Then what is the time taken by the body to reach the ground? T is equal to root of 2h by g. What is the final velocity of the body to reach the ground? V is equal to root of 2gh. In this case, what is the time of ascent of the body? U by g. This is called time of ascent. Then, what is the maximum reached by the body? H max is equal to U square by 2. So, in this case, we have two formulas. Here, there is no formula applied directly concept. So, here, mainly, you consider that initial velocity is replaced by minus U. V is equal to U plus 18, S is equal to UT plus half h square. In those all four equations, U is replaced by minus U in this case. But this third case is given, third case and fourth case is given in so many times in the entrance exam point of view. Now present trend, they are given the third case and fourth case. Okay. Now here there is no formulas to remember the third case and fourth case. So this is about our four equations of motion. This is about our four equations of motion in case of a motion under gravity. This is our motion in a straight line chapter 1 topic. Right? What are the four equations? What is the four equations? V is equal to U plus 18, S is equal to UT plus half h square, and V square minus U square is equal to 2as, and Sn is equal to U plus A into n minus of. Once you remember, these four equations are valid only for constant acceleration only. These four equations are not valid for variable acceleration. These four equations are not valid in our variable acceleration. These four equations are valid for constant acceleration. Okay? Now we start.